All right, so I would like you to get out your note sheets, the notes sheets that we started on Tuesday. And I would like to go over the 3 remaining problems that we did not get to. And it's 5, 6, and 7. So I want to start with 5. I always say underline, oh, no. Underline, that is just not what I want. Underline what you're given, circle what you're trying to find. Underline what you're given, circle what you're trying to find. Underline what you're given, circle what you're trying to find. All right, so this one, we're given 4 moles of neon, so we need to get in the habit of writing 4 moles of neon. And you need to write the NE. These problems, it's easy because we're only using one substance, but we will be getting into problems that we're going to be using multiple substances, so you have to make sure you keep them all straight. So since moles were out front, you need to put 1 mole of neon on the bottom, and we are looking for molecules. Do we have a direct relationship between moles and molecules? We do. We know that there's 6.02 times 10 to the 23 molecules in 1 mole of neon. If you want to use 6.022 times 10 to the 23rd, that is okay. So if we look at units, these units are going to cancel, and we're going to be left with molecules. So you don't even need this second set of parentheses. So when you're putting this in your calculator, it's 4 times 6.02 EE23 divided by 1, and it is 2.41 times 10 to the 24th molecules of Ne. If you are off by a tenth, you're just putting it in your calculator wrong, and if you show me what you're doing, I could probably fix that for you. The next one, you're given moles of NH3. You write down your moles of NH3. Since moles is out front, you have to put 1 mole of NH3 on the bottom. Now I could put grams up here, but they don't want grams. I can put molecules up here, but they don't want molecules. They want hydrogen. So what you have to do is look, how many hydrogens are here? There's 3. So you have to put 3 moles of H in 1 mole of NH3. And if we wanted to look at units, your moles of NH3 are gone. Now you're left with just H. So now in order to cancel out my moles of H, I have to put 1 mole of H on the bottom. And I know that there's 6.02 times 10 to the 23 H atoms in 1 mole. Your moles of H cancel, and you are left with hydrogen atoms. When you're going to solve this, it's 4 times 3 divided by 1 times 6.02 EE23. And your answer is 7.22 times 10 to the 24th hydrogen atoms. Okay? Let's do the last one. We're given 12 grams of copper 2 acetate. That's the chemical formula for copper 2 acetate. Up here was ammonia, and this was neon. All right, so right off the bat, I know that I have to get grams out of there. So I know I'm going to have grams of copper 2 acetate on the bottom. When you're figuring out your grams of copper 2 acetate, this is where people make their mistakes. I have 1 copper, I have 4 carbons, I have 6 hydrogens, and I have 4 oxygens. So let's add them all up. And you should get 181.65 grams. What's always, always, always on the opposite side of grams? 1 mole of copper 2 acetate. So if I would cross out my units, my grams cancel. Now I'm left with 1 mole of copper 2 acetate. But I do not want copper 2 acetate, I want hydrogen. So I have to bring 1 mole of copper 2 acetate down here to cancel. And I know there's 6 moles of hydrogen in my copper 2 acetate. Then I can say 1 mole of hydrogen down here to cancel. And I know that there's 6.02 times 10 to the 23 hydrogen atoms in 1 mole. So you have 12 times 1 divided by 181.65 times 6 times 6.02 EE23, and you get 2.39 times 10 to the 23rd hydrogen atoms. Okay? Any questions? All right, I wanted to make sure that we had those last 3 notes filled in, and we can work on our homework now. Thanks.